Hello students, I hope you all are doing good and preparing well for DCET exam. So this is the second series that is a continuation of the previous series. So if you have followed my previous series, there I have covered the straight lines topic. So the entire topic is covered, so you can refer to that. So today we are starting a new topic, and that is trigonometry. So in this series, we will be covering the different topics of trigonometry. So today's session is a very basic session, so all the basic concepts we'll be covering here. There is no prerequisite for this topic. I'll be covering from the basic and we'll go till the advanced level, whatever is required for the examination. Okay. Yeah. So let's look at the syllabus. Okay. What is there for the examination? So these are the different topics. Right. So in today's session, we will be covering this thing: the concept of angle, their measurement, radian measure, and related conversion. So this is a very important chapter. Okay, a very important topic, and this will become the base for these topics. Okay, so this is a important video. Moving on. I have broken down all the concepts that we are going to cover today. The first thing will be the concept of angles. Okay, what are angles? Then how do we measure the angles? Okay, then what are the different units to measure them? That are radian, degree. Then how to convert between degrees and radians. Okay, that is also important. Then we'll dig deeper into basics of trigonometry, like basics: what is sine, cos, tan. Okay, if you are a CBSE student, you might have read this, but if you are from state syllabus background, so this is something new for you guys. So we'll be covering that also. Okay, so let's start. So it is an interesting topic. So first thing is angles. Okay, so before going to angles, I would like to ask you one question. Say a person is moving from point A to point B. Okay, so what do you say? He has covered some distance, right, in this direction, say 5 meters. So distance is measured using some, like 5 meters. This is the unit we have used to measure distance. Okay, say I have this line. Okay, if this line rotates in this direction, in anti-clockwise direction, this is the initial side and this is my terminal side. It started from here and this is the final position. So it is rotated. A line is rotated. So how do we measure a rotation? Okay, so there we come across angles. So to measure the rotation, to measure the rotation, we need angles. Okay, that is where we need angles. So rotation is measured using angles. Okay, this is clear. Moving on, and I would suggest you to watch the video at 1.25 or 1.5, depending on your like whatever is the pace you feel comfortable. Okay, so till now, so what we have learned is angle. Angle is a measure of rotation. Okay, next, next again is an important concept, very important. So this is the sign convention. Okay, the sign convention. There is a sign convention for angles. So what is this? So okay, very easy. So if you are going in anti-clockwise direction, this is anti-clockwise, right? If you are going in anti-clockwise direction, this is taken as a positive angle. Okay, this is our reference line, x-axis, positive x-axis. Positive x-axis is my reference line, and if I go in clockwise direction, okay, this direction, this is taken as negative. Okay, this is my x-axis. If I go in anti-clockwise direction, it is positive angle, and if I go in clockwise direction, the angle is negative. Okay, so I'll just make it clear. Say this angle, the direction of the angle, look at here, this is 30 degrees. Okay, example I am just giving you. Similarly, minus 30. So here the direction I have to show like this, in clockwise direction. This is minus 30. This is very important. Okay, so you should look for the direction, whatever the direction it is, whether it is clockwise or anti-clockwise. Depending on that, we measure the angles. So this is degrees. So here I have just shown 30 degrees, minus 30 degrees, and so on. Okay, so what is a degree measure? Okay, so I have already introduced, but okay, I'll just define what exactly is a degree. So we need some unit to measure the rotation. To measure the rotation, we need some unit. Like for distance we have meter, kilometer, centimeter. Okay, similarly for rotation we have a we have some unit. Okay, so that is degree. So what is a degree? What is 1 degrees? Okay, okay, so if I make a complete rotation from here to here, okay, complete rotation. So let's imagine a circle. Okay, it becomes easier. Okay, if I divide this circle into 360 parts, so like this I'm dividing. So these are 360 parts, 1, 2, 3, 4, so on till 360. Okay, I have divided a circle into 360 parts. So if I take one slice of this, okay, I'm just showing you, I'm taking one slice from this. So whatever this angle is, say this is theta, this theta is called 1 degree. This is the definition of degree. This is 1 degree. Okay, so I'll just repeat. We have taken a circle and divided it into, divide into 360 parts. 360 parts. You might get the question, "Ki, why 360, sir? Why not 100 or 200?" So that is a standard thing. So they have chosen this number 360. They have divided a circle into 360 parts. Okay, equal parts. 360 equal parts. Each part, if I take one single part, okay, and if I see whatever this angle is there, that is called 1 degree. I can take any circle. Okay, I can take any circle. This angle is going to remain same. 1 degree is 1 degree for any circle. If I take a smaller circle or a bigger circle, this 1 degree is going to remain the same thing. Okay, this 1 degree will be 1 degree only. Okay, so that is the concept of degree. Okay, so you all got that, what is a degree. So we'll be measuring angles in degree, and there is one more unit which we are going to study, that is a radian measure. So you should also know what is radian measure. Till now what we did was degree measure, but radian is important, and this is what mostly we will be using in trigonometry. So let us see the definition. What does it say? 1 radian is the angle made at the center of a circle by an arc whose length is equal to radius of the circle. So let's try to understand this. See, we have got a circle. Okay, it says the what is 1 radian? They are defining 1 radian. What is 1 radian? 1 radian. So 1 radian is nothing but, if I have an arc, this is my arc. Okay, I'm just highlighting this. If this uh, arc length is equal to r units, is equal to 1 r. Okay, let me just write it as 1 r. Okay, r can be anything. R can be 5 meter. R is here, let's say 2 meters. So this arc length will become, as it is 1 r, it will become 2 meters. So whatever the angle this arc makes here, this angle, let us call this theta, that is radian. 1 radian, this theta is equal to 1 radian. because the arc length is equal to the length of the radius, because arc length is equal to 1 r. Okay, just try to understand. This arc length is equal to the length of the radius. Okay, length of the radius, I'm writing it as 1 r. Okay, or just r. Say in this case it is 2 meters. Okay, because the radius of the circle is 2 meters. Whatever the angle it subtends, whatever the angle we get for this particular arc, okay, that is called radian. 1 radian, it is called 1 radian. Okay, very important. So 1 radian is, uh, we get 1 radian when an arc of length equal to the radius, okay, whatever angle that it subtends is called 1 radian. Okay, let us just recapitulate. See, again the same thing here. This arc length is equal to radius. Okay, and whatever angle we get is called 1 radian. Okay, so let's try to understand this deeper. See, I have got an arc, say 2r. The length of this arc is 2r. So what will be my angle? Will be equal to 2 radians. Similarly, if I have an arc whose length is equal to 1.5 r, tell me what will be this angle? This theta angle will be 1.5 radian. Okay. Similarly, if I have like this, say like this entire thing, say it is say 3.4 r, the length of this arc is equal to 3.4 r, then what will be this? This will be nothing but 3.4 radian. So what do you observe here? What do you observe here? Our theta is nothing but uh, okay, the relation is L is equal to r theta. Okay, let me just tell you this. Yeah, so here arc length, whatever is our arc length, L is our arc length. Arc length is nothing but r times of theta, right? Theta is in radians. Theta is in radians. Okay, r is the radius. So if you compare all these three with this, what do you get? L is equal to r theta. L is equal to r theta. Just observe here. The length of the arc is 2r. The radian is also 2. Here 1.5 r is the length of the arc. The angle subtended is 1.5. Similarly here the radian measure is 3.4. So to get the arc length, what we have to do? We just need to multiply that angle with r. That will give us the length of the arc. L is equal to r theta. Let me just write it properly here. So L is equal to r theta. So this is the relation that you need to remember. The arc length is nothing but r times of theta, but theta is in radians. This is very important. Most of the students make mistakes here. Theta is in radian. This won't work if our theta is in degrees. It won't work. This formula won't work. So L is equal to r theta is very important. Moving on. Uh, so one more important observation that I want to tell you guys. Okay, now we can cover it here. The relation between the radian and degree. Say I have got a circle here. Okay. Okay. So tell me what is the perimeter of a circle? Perimeter. We have learnt in our lower classes. It is nothing but 2 pi r. Right. So this 2 pi, I can write it as 6.28. Am I right? Okay. So if I start from this point, okay, and I take a complete rotation and come back here, so I'll get some angle here. This angle let me call theta. because this arc length is 6.28 r, that means this theta will be equal to 6.28. Am I right with our logic? Right. So can I equate 6.28 is nothing but 360 degrees? Am I right? 6.28 is nothing but 2 pi. 2 pi is equal to 360 degrees. So 2 pi is radian. Okay, this is radian. This is degrees. Okay, the important relation, I'll just repeat. So perimeter is equal to 2 pi r. So perimeter can be written as 6.28 r, right? So if a complete circle, if you are taking that, the arc length of the arc will be 6.28 r. With this logic, the angle that it subtends will be equal to 6.28 radians. So 6.28 radians is equal to 360 degrees. So 6.28 is nothing but 2 pi, right? 2 pi is equal to 360. Okay, if I divide by 2 on both the sides, I'll get pi is equal to 180 degrees. So this is a very important relation, you need to remember this. Okay, pi radians is equal to 180 degrees. If you know this relation, you can easily convert in between. Okay, so what is 1 radian? 1 radian is nothing but dividing by pi on both the sides, we'll get 180 by pi, right? If I divide for this equation on both sides by 180, what do I get? 1 degree, right? So 1 degree is equal to pi by 180 radians. This is degree. So this is something important that you should know. So these are the two things you need to remember. Pi radians is equal to 180 degrees. 1 radian is equal to 180 by pi, and 1 degree is equal to pi by 180. Okay, yeah. Moving on. So here we'll be solving a question. Find the radius of the circle in which a central angle of 60 degree intercepts an arc of length 37.4. So here we'll be making use of this formula that I have told you. L is equal to r theta. So see here, L length and arc of length, L is given to us, that is 37.4. R also we have to take in the same unit, that is centimeter. They are asking us the radius. Radius is, we don't know. Theta, as you all know, it should be in radians. Okay. So, but we have got it in degrees. So we have to convert this to radians. We know 180 degrees is equal to pi radians. So what is 60 degrees? Okay, simple cross multiplication, right? 60 into pi by 180. This is nothing but 61 is 60, 3 is this pi by 3. Pi by 3 radians. Very important. All I have to do is put it in this formula. So R is equal to L by theta. L they have already given us 37.4. Theta in radians is pi by 3. So if you solve this, you will get the radius. Okay, this is how you solve. So this relation is important. And one more thing we did was, we did not take 60 degrees directly. We took it in radian measure. Radians is very important. Okay, moving on. Okay, the minute hand of a watch is 1.5 centimeters long. How far does its tip move in 40 minutes? Okay, so minute hand, this is nothing but the radius, right? Radius is equal to 1.5 centimeter. Here, if you have read the question properly, they are asking us the arc length. Angle they have given it as 40 minutes. Okay, you have a watch. So minute hand, from here it has started, and at 40, 40 is somewhere here. So this is the angle. So what will be this angle? Tell me. We can find that out. Okay. So 60 minutes is 360 degrees. So what is 40 minutes? it is nothing but 40 into 360 by 60, which is nothing but 240, 240 degrees. Okay, but 240 we cannot use, we have to convert this into radians. We know that 180 degrees is equal to pi radians. So what is 240? We need to find that out, which is nothing but 240 into pi by 180. 3 6 are 3 8 are 2 4s are 2 3s are, so this is 4 pi by 3. This is in radians. So we have got the radius, we have got the angle, we need to find the L, the arc length. So the relation that we know is L is equal to R times of theta. Directly R is 1.5, theta is 4 pi by 3. So this on solving this, we get this in centimeters because our R was in centimeter. You can solve that and find out. So some standard angles that you are supposed to remember. So we'll be converting. So 30 degrees, we know 180 degrees is pi radians. 30 degrees is pi into 30 by 180, 30 36. So this is pi by 6. Similarly, if you find out for 45 degrees, so just work out, you can pause and work this out. I'll be writing it directly, but please pause and try to do all of this. So it is nothing but pi by 4. This is pi by 3. We did it just now. This is pi by 2. 180. 180 is like half. Half is pi. Okay. This is something you should remember. You should know. Okay. Moving on. So again, interesting question. Convert 40 degrees 20 minutes. This is minutes. Okay. I have not covered this in the chapter, but I will be covering that now. Into radian measure. Okay. So 20 minutes. So first we should convert this in radian degrees. So there is one more thing. 60 minutes is equal to 1 degree. This is the definition. Okay, just don't bother uh, more about this. 60 minutes is equal to 1 degree. So what is 20 minutes? This is nothing but 20 by 60, which is nothing but 1 by 3 degrees. So 1 by 3 degrees. So I can write 40 degrees 20 minutes in terms of degrees as 41 by 3 degree, right? Okay, so this is a mixed fraction. I can write this as 121 by 3 degrees. Okay, and I know 180 is equal to pi radians, then 121 by 3 is equal to 121 by 3 pi by 180. Right, on solving this I'll get something that is nothing but my radian measure. You can solve that. Okay, please solve that and find out. Okay, you can put that in the comment section so you guys can cross verify each other. So you just need to solve this and do. Yeah, I hope. Yeah, so that was all about introduction to angles, basic thing. Next, I think this video is getting longer. We'll cover trigonometry in our next session. Okay, so I would suggest you to practice more questions on this. You can find the questions in NCERT textbook class 11. That first exercise, you can solve the questions from there. For solutions, you can refer. You will get online. All the solutions you will get online easily. Okay, so you can refer those solutions. You can easily understand the solutions. So I would suggest you to practice more. Okay, yeah, that was all for today's video, today's session. I hope this session was helpful. If this was helpful to you, please like the video and try to share this video in your class WhatsApp group so that more students get the benefit of this. Uh, yeah, and you can also join my Telegram group. And if you have any doubts, you can put it there. I'll try to solve it. Okay, so that was all. Thank you.